Hello and welcome guys to my YouTube channel. In today's video, we will be covering operations on upper and lower bound, and we will be finishing up everything that you need to know about upper and lower bound. Now, when we're talking about operations, we're talking about multiplication, addition, subtraction, division, powers, all of it. Now, what you need to understand is as follows. So, let's say you have two numbers, A and B. We will be representing them by variables, okay? So well, the thing is that A has an upper bound and a lower bound, and B as well has an upper bound and a lower bound. Okay? And you see, your result by multiplying A and B will be stored in C. Okay? So basically, you can choose any combination really. You might choose, for example, the upper bound of A multiplied by the lower bound of B, or the opposite, or both upper bounds. The question is, what do I want to achieve? Well, here's the thing. Let's say you want to achieve the maximum possible value of C, okay? Or the upper bound of C. You see, the maximum possible value and the upper bound of C are the same thing. So we're gonna be using these terms interchangeably, okay? And let's say over here you always want to find the minimum possible value of C, or the lower bound of C. So once again, the lower bound and the minimum of C are terms that we use interchangeably. Okay? Now, let's take a look here. So we have multiplication. Now, what you need to understand about multiplication is that if you want C upper bound or maximum of C, then you would take the upper bound of A and the upper bound of B. And it makes sense because in multiplication, you would need this number over here to be the highest possible, so the upper bound, and this number over here, the highest possible, the upper bound. So if you take the highest possible for both and multiply them, you would get the highest possible of C, basically, like the result, essentially, okay? Now, let's say I wanted to get the minimum possible value of C, then you would take the lower bound for A and multiply that by the lower bound for B, okay? I hope this makes sense. Now, for addition, it's the same thing. You're adding two numbers. So if you have a bigger number here and a bigger number here, you would get the maximum result. So you would take A upper bound as well and add it to B upper bound. Okay? And if you want to achieve the maximum of C. Everything on the left-hand side over here will be the max of C. Now, if you want to achieve the minimum of C or the lower bound of C, then you would take the lower bound for A and add it to the lower bound of B. Okay? So you would have, this way you would have the minimum possible value for C. Okay? Now, powers and roots. So let's say that C is equal to A to the power of N, where N is bigger than 1. So N could be any number, like that's bigger than 1. It could be 1.5, it could be 2, it could be 3, and so on, okay? Now, A has an upper bound and a lower bound, okay? So, in order to achieve the maximum possible value of C, well, obviously, you would want A to have the upper bound and then get raised to the power of N, whatever N is, could be 2, 3, 4, and so on. Because the bigger the number that is in here, the bigger your result will be, and that's what we want. Now, what if you wanted to achieve the minimum possible value? You would take the lower bound for A and raise it to the power. Because again, the lower the number inside the power, the lower your result will be. And that's what you want to achieve here. You want the minimum possible C. Okay? Now, moving on to roots. So, again, over here, let's say you took the root of 4 versus the root of 16. Root of 4 will give you 2, and the root of 16 will give you 4. So, as you can see, the bigger the number inside the root, the bigger your result will be. So, if you want to achieve the maximum possible value of C, then you would take the upper bound for A. And if you want to achieve the minimum value of C, you would take the lower bound of A, okay? So I hope this is so far clear. So with multiplication, addition, powers, and roots, it's kind of all the same. If you want to get the maximum or the upper bound of C, you would take the upper bound for A and the upper bound for B, okay? Because multiplying the maximum of the two numbers will give you the maximum possible result. And the same thing goes for the lower bound. Same thing goes for addition, for powers, and for roots, okay? So they're fairly simple to follow. Now, subtraction and division are a little bit different, okay? So let's talk about subtraction. Yes, subtraction. Now, I will firstly explain this using a number line so you can actually understand what's going on. Now, let's say you have this number line, and let's say you have A right here as 4. And let's say you have, so this is A. And let's say you have B right here as 2. Now, both of those, let's say they're rounded to the nearest whole number. So the upper bound for A would be 4.5. This is the upper bound. And the lower bound would be 3.5. As for the 2, the upper bound would be 2.5, and the lower bound would be 1.5. Okay? If you're unsure how these results came to be, you would have either not watched the past video about upper and lower bounds, or you forgot how we find upper and lower bounds. So I would highly recommend you go back and watch it before you continue. Now we're going to be subtracting, okay? We're going to be subtracting A minus B, okay? So subtraction is basically the distance or the difference between them. Now, as you can remember, we want to achieve the maximum possible value of C in this side of the table. So in order to achieve the maximum value of C, you would want the maximum distance between them. So firstly, think about it for a second. How would you get the maximum distance? Would you take for example, the lower bound for A and the lower bound for B? Or how would you do it? I forgot to label this. This is B, by the way. Now the answer would be taking the upper bound of A minus the lower bound of B. This is the maximum possible distance, okay? So in order to achieve C max, you would take the upper bound of A and subtract the lower bound of B, okay? As you can see here. Now, what if on the right-hand side, you want to achieve the minimum difference, okay? In that case, you would take the lower bound of A and subtract the upper bound of B. This is the closest we can get them, so the result will be the least possible. So it will be A lower bound minus B upper bound. Okay? So as you can see here, I hope you understand where these results come from. So again, you need to understand that subtraction is the difference or the distance between two different numbers, okay? So when I say C max, which is the result, that means I want the maximum distance. So this right here is the maximum distance. It's A upper bound minus B lower bound. And if I want the minimum distance, then it's A lower bound minus B upper bound, okay? So I hope you understand this. Some students find it easier to just memorize it. So if you do want to just memorize the rule, then basically C max is the same as C upper bound, remember? So both of them are the same thing. So basically you want upper bound, right? So upper bound, lower bound, you know? So you subtract the lower bound from the upper bound. So it's upper, lower. Now, if you want C lower bound, then lower bound is lower bound minus upper bound, you know? So it alternates, but it starts with the same thing. Upper, lower, lower, upper. Okay? Now, what about division? Well, so with division, I'm going to write it down firstly as A over B, okay? Now, as you remember, on this side, we want to get the maximum of C, so C max, or the upper bound of C, right? So let's say you had a bunch of chocolates and you want to divide them on a number of people. So this is the amount of chocolate you have, and this is the number of people. Okay? So you want C max. That is the result of dividing A by B. Now, if you divide the number of chocolate you have by the number of people, you would achieve basically how much chocolate, how many pieces of chocolate will every person get, correct? So let's say you want the maximum possible. You want the maximum amount that every person can get. Would you want to have a higher amount of chocolate or a lower amount? Definitely a higher amount. So an upper bound for A, okay? And would you want to have a higher number of people to give it to or a lower number of people? Of course, a lower number of people. A lower number of people means more per person. So the lower bound for B. So that's the thing. So if you want to get the upper bound or the maximum of C, you would want the upper bound of A and divide that by the lower bound of B. Okay? And of course, you can rewrite this as a fraction. We would be mostly dealing with it as a fraction anyways. Okay, so this is the upper bound of A, and this is lower bound of B, okay? Now, let's say you want to achieve C minimum or C lower bound. Now, in that case, again, it's the same example, A over B, with the chocolate and the people. Now, let's say you want to give the least possible amount of chocolate to each person. You would decrease the amount of chocolate. So this way there is less to go around people. And so we're taking the lower bound for A. And you would increase the amount of people that you give it to. By increasing that, people would have a lot less chocolate. Each person will receive a lot less, okay? So the lower bound for A and the upper bound for B. So that's the thing. So if you want to achieve C minimum or C lower bound, you would choose the lower bound for A and divide that by the upper bound of B, okay? So A lower bound over B upper bound, okay? As you can notice, by the way, it's the same as a subtraction. The first one, if you want an upper, the first is an upper, and the second is a lower, okay? And if you want a lower bound for C, the first is a lower, and the second is an upper, okay? So if you feel more comfortable in memorizing those rules, there's nothing wrong with that. But it's really important to actually also understand where they come from, okay? The logic behind them. Okay, so yes, so basically multiplication, addition, powers, and roots are very straightforward. It's always upper bound, or lower bound, lower bound. And however, subtraction and division have a mix, okay? And I hope you understood how they work. Now, let's take a look at some examples. So given that m is equal to 7.5, correct to 1 decimal place, and n is equal to 2.3 to 2 significant figures. Okay, so this is rounded to 1 decimal place, and this is rounded to 2 significant figures. Now, as you can see here, they want, for example, the maximum possible value of m times n, the minimum of m minus n. Now, some students prefer getting the upper and lower bounds on demand. So, they would basically find the upper or the lower based on their needs. Okay. But right now, what I'm going to do is I'm going to find the upper and lower bounds for both m, both n, so that they are ready to use. Okay. So let's start with m. So m is 7.5, correct to 1 decimal place. So this is the first decimal place. I'm going to replace that by 1. And the rest turns to 0. Dividing this by 2 is 0.05. So the upper bound for m is going to be 7.5 plus 0.05, which is 7.55. And the lower bound for m is going to be 7.5 minus 0.05, which is 7.45, okay? This skill, you should already know it from last video, okay? So again, if you didn't watch the last video, I would highly recommend you go watch it first. Now, for n, it's 2.3, rounded to 2 significant figures. This is the first significant, and this is the second. So we're going to put a 1 here, change everything else to 0, divide it by 2 to find the error, and we get 0.05. This is my error. And so the upper bound for n is 2.35, and the lower bound is 2.25, okay? Now I'm going to write those down here. So m, upper bound is 7.55, and lower bound is 7.45. And for n, the upper bound is 2.35, and the lower bound is 2.25, okay? So now let's take a look at what the question wants. So part A. The maximum possible value of m times n. Okay, so we are going to multiply m times n, and we want to achieve the max, or otherwise known as the upper bound, okay? So, as you remember from what we explained in the table, when we're multiplying two variables and we want the maximum or the upper bound, we would take the upper bound for the first variable and the upper bound for the second variable, okay? So the upper bound for m is 7.55, and the upper bound for n is it's 2.35, okay? And now you can just go ahead and plug these numbers on your calculator, and we get 17.7425. Now, if I want to round this to 3 significant figures as usual, it's 17.7, okay? So this is the answer. This is the maximum possible number you can get out of multiplying m by n, okay? Because the maximum m can be is 7.55, and the maximum that n can be is 2.35, okay? So this is the maximum. Moving on to part B. The minimum possible value for m minus n. Okay, so we want m minus n, and we want to achieve the minimum. Okay. Now, as I've said previously, the minimum or the lower bound for the result, basically, or the overall result, okay? Now, in order to find that, again, as you remember in the table, we said that if you want to find if you want to find the result as a lower bound, then we will take the lower bound for the first one and the upper bound for the second one, okay? If you don't remember this, go back and check the table. So the lower bound for m, I can just get it right here. It's 7.45 minus the upper bound for n is 2.35. Okay. And so you can just plug those numbers on your calculator and we get the result as 5.1. Okay? So basically this right here, this is the minimum possible value that you can achieve from subtracting m minus n. And we achieved that by subtracting the lower bound of m minus the upper bound of n. Okay? Now for part C, I will be solving it right here because we have some space. Alright, so C. They want the upper bound of m divided by n. Okay, so m divided by n, they want the upper bound for this, or the maximum possible value. Okay? In order to achieve the upper bound for the division, the first one upper bound and the second one will be lower bound. Okay? Like I said, if you want to go on this based on memorization, which by the way I would recommend, to be honest, because if you're gonna figure out the rule all over again every time in the exam, it's gonna take too long. Okay? So it's easier and just faster. And with time you'll memorize it easily. So again, so we take upper bound for m and lower bound for n. So the upper bound for m is 7.55 divided by the lower bound for n, which is 2.25. Okay? And you can just go ahead and plug this on the calculator and you'll get 151 over 45, or basically rounded three significant figures, this would be 3.36. Okay? This is the result. Okay, let's move on to part D. So they want the maximum value of the square root of n. So we want to achieve the maximum or the upper bound of taking a square root for n. Now, in order to do that, again, we would take the upper bound for n and then take the square root. So the square root basically of n upper bound is 2.35. Square root of 2.35, and we would get 1.53. This is rounded to three significant figures. Okay? Now let's move on to part F. I scrolled way down. Okay, part F. Now part F wants the minimum value of m minus n over m. So we want the minimum or the lower bound for m minus n over m. Okay. Now, how would we think about such a question? So here's the thing. You need to think basically from outside and then get into the specifics, okay? So let's take a look here. Now, think about it this way. What is the last operation you would do? Like, let's say you had the numbers over here. The first thing you would do is the subtraction above. And after you do that, you would divide the number above by m, correct? So this division right here, this is the last thing you'll do, really, correct? So in that case, you would think as a big whole operation that this is division. And I want to achieve the lower bound for this whole division. In that case, if you want to achieve the lower bound, we said that we'll take the lower bound for the first one and the upper bound for the second one. This is how we achieve the lower bound for the division. Okay? So now we want, basically, we know that we want the lower bound for the top part and the upper bound for the bottom part, correct? Now the bottom part is simply m, so I simply want upper bound for m. However, the upper part, well, you want the lower bound overall, but you have two variables inside. You have m minus n. So now I think, okay, so I want the lower bound for the subtraction operation over here. How can I achieve that? Well, if you want the lower bound for a subtraction, then you would want the lower bound for the first one and the upper bound for the second one. Okay? And this is how you basically solve this. Now we know fully that in order to get the result we want, we basically want the lower bound for m over here minus the upper bound for n over the upper bound for m. All of this would achieve the lower bound for the whole result, okay? So now we can start to put our numbers. So we know that the upper bound, the lower bound for m is 7.45, and the upper bound for n is 2.35, divided by the upper bound for m, which is 7.55. Okay. And now I can just go ahead and plug those numbers on my calculator. We'll get our result. Now, rounded to three significant figures, you get 0.675, okay? This is the final answer. So I hope this was clear. If you understood it fully, you can skip to the next, but I will repeat explaining just one more time. So again, you have m minus n divided by m. Now again, you have to think, what is the last operation I will do? The first one will be subtracting m minus n, okay? And then you will divide it by m. So this division right here is the last operation. Now with that last operation, you start thinking, okay, so I will have a number here, a result, and I will have a number right here. And the number, and what we want to achieve is a lower bound for this division. So in order to achieve a lower bound, we would have a lower bound for the top part and an upper bound for the bottom part. Now the good thing is that the bottom part only has m alone, so all you want is an upper bound for m. That's it, done with the bottom part. Okay? Now for the top part, the numerator, you would want the lower bound, correct? So in order to achieve the lower bound for a subtraction, you would want the lower bound for the first one and the upper bound for the second one. And that's it. This is how you found out that what you want for each variable, what value should it take. So m should take a lower bound, n upper bound, and m down here upper bound. Okay? Hopefully this is clear. Okay, moving on to the next example. Now, given that a is equal to 9.56 and b is equal to 3.12, both correct, 2 decimal places, determine the lower bound for c is equal to a times b over a plus b. Okay? By the way, a really common mistake for some students is that they go ahead and just substitute like 9.56 multiplied by 3.12 over 9.56 plus 3.12, and they get a value for c, and then they find the lower bound for c, like by subtracting half or something. This is completely wrong. Okay, never do this, because c is the result of a and b and the operations between them. What you need to do is find upper and lower bounds for a and b, okay? Because they're the values that are being rounded to 2 decimal places. Now let's go ahead and think about this. So we want c basically equal to a times b over a plus b. Now, as we previously stated, we need to take a look, what's the last operation I will do? The first operation will be a times b, and then a plus b, and then I will divide the result from a times b divided by a plus b. So this division right here, this is the last operation. So we want the lower bound for c, or the minimum, okay? Or the minimum. To achieve that, we would want the lower bound for the top part, the numerator, and the upper bound for the lower part, okay? Overall. Now I will go into the specifics. Now, let's take a look at the top part. So we have a times b, and we want a lower bound for it overall. So in that case, this is a multiplication. So you want the lower bound for the first and the lower bound for the second. Lower bound times the lower bound will give me a lower bound. So that's it for the top part. The numerator is done. Let me write this more clearly. So this is LB. Now for the bottom part, we want to achieve upper bound overall, okay? And we have an addition. So to achieve an upper bound from two variables being added, we would want the upper bound from the first and the upper bound from the second as well, okay? And that's it. Now you know that each and every single variable, what bound will you take for it, okay? So now let's go ahead and find a lower and upper bound and also B and lower and upper bound, okay? So A is equal to 9.56 and it's being rounded to 2 decimal places. So 2 decimal places, this is the first decimal, this is the second. Replace the second by 1, turn everything else to a 0, divide the unit of round by 2, and this gives us 0.005. This is my error. Now, A, upper bound, is the addition of 9.56 plus 0.005, which gives me 0.565, okay? And A lower bound is the subtraction of 9.56 minus 0.005, which gives me 9.555, okay? Now, as for B is equal to 3.12, also rounded 2 decimal places. The unit of round is 0.01. Dividing this by 2, we get also 0.05. And so B upper bound is the addition, 3.12 plus the error, gives you 3.125. And B lower bound is 3.115. Now I'm going to go ahead and substitute my variables. So A lower bound, which is 9.555, multiplied by B lower bound, which is 3.115 over A lower bound, A upper bound, which is 9.565 plus B upper bound, which is 3.125. And now you can go ahead and plug all of those numbers on your calculator. Okay, so we get 2.35. Okay, this answer is already rounded to 3 significant figures, okay? So again, this is the lower bound for C, the minimum of C. We did that by taking lower bound multiplied by lower bound divided by upper bound plus upper bound. Okay, next example. Now, P is equal to 8.4, Q is equal to 33, and R is 5.6, all correct to 2 significant figures. Determine the maximum value of C, where C is equal to P times Q minus R plus R. Okay, I'm gonna write this down. Now, let's take a look here. So, as I've previously mentioned, we need to understand what's the last operation that will happen. Now, the first one, following BIDMAS, will be the brackets, Q minus R. And then the result will be multiplied by P. And then finally, we will add this result overall. This whole thing will be added to R. Now, we need to remember, we want the maximum of C, or the upper bound of C. Okay? So you would have this entire thing plus R, and we want to get an upper bound. So obviously, we would want an upper bound because this is a plus and an upper bound over here. Now, R is already an upper bound. Sorry, I mean R is alone, so you can just take an upper bound for it directly. Now over here, we have P times Q minus R, a whole expression that we want the upper bound from. So now we'll break it down further. So let's take a look here. So what's the last operation that will happen within this expression? Well, firstly, Q minus R will happen, brackets, and then the result will be multiplied by P. So you basically have an expression, Q minus R, and it will get multiplied by P eventually. So, and we want to achieve an upper bound for this whole expression. So this is a multiplication. To achieve the upper bound for multiplication, you would want an upper bound over here and an upper bound over here, okay? So P, we would want an upper bound. And Q minus R, the entire bracket, you want an upper bound for it, okay? I'm gonna erase the parts at the bottom over here. Okay, now finally, Q minus R, we want an upper bound for it. So this is a subtraction. To get an upper bound from a subtraction, the first one needs to be upper bound and the second one lower bound, okay? And now I finally know exactly what each variable should be, whether upper or lower bound, okay? So now let's go ahead and find the upper bound and lower bound for each. Let's start with P. So P is equal to 8.4, rounded to two significant figures. So this is the first significant and this is the second significant. We'll replace this by a 1, and this is 0.1. Dividing this by 2 gives us 0.05, okay? So now P will basically be P upper bound is 8.4 plus 0.05, which is 8.45, okay? Now for Q, it's 33, and we want to find the upper bound of Q. So this is the first significant, this is the second significant. We'll replace this by a 1. Everything else turns to a 0, but there's no need to put a 0 on the left side. We explained this last video. And now we'll divide this by 2, we get 0.5. And so Q upper bound is equal to 32.5. I'm sorry, I accidentally subtracted. Upper bound, we add them, so 33.5. Okay. Finally, R. R is 5.6, correct to two significant figures as well. This right here is the second significant. Everything else turns to a 0. Divided by 2, 0.05. Now notice something. For R, we actually want the upper and the lower bound, both of them. So R upper bound is equal to the addition, which gives you 5.65. And R lower bound is subtraction, which gives you 5.55, okay? Now, so basically, we'll substitute our variables. P upper bound is 8.45 multiplied by Q upper bound, which is 33.5 minus R lower bound, which is 5.55 plus R upper bound, which is 5.65. Okay? And now you can go ahead and plug all of those numbers on your calculator as a whole expression. Make sure you put the brackets on your calculator. And we get the final result as 241.8275, okay? Now, to three significant figures, this would be 242. Let me just remove this dot. Okay, that's it. This is the final answer. Okay, now let's take a look at some exercises. As usual, you should pause the video, try to solve it on your own, and then check your answer. Okay, so M is equal to K over T minus A. And here we're being given the values of K, T, and A, and the unit of round. Work out the minimum value of M. Okay, so we want minimum of M, or, again, lower bound of M. Now, M is equal to K over T minus A. Now, let's take a look here. The last operation that will happen is this division right here, correct? So in order to get a lower bound from this overall division, you would want the lower bound from the numerator and the upper bound from the denominator, okay? Now, the numerator is one variable, which is K, so I can just go ahead and say that we want the lower bound of K. As for the denominator, we have T minus A, okay? So it's a subtraction, and we want the upper bound for this expression. For subtraction, if we want to get the upper bound, we want the upper bound from the first one and the lower bound from the subtracted number, okay? So that's it. So I want the lower bound for K, the upper bound for T, and the lower bound for A. Now let's go ahead and find each of those. So we have firstly k equal to 14, correct to two significant figures. So the two significant figures, firstly, this is the first one, this is the second one, this is 1, divided by 2, 0.5. So k lower bound will be 13.5, okay? T is equal to 7.8. The unit of round will be 0.1. Dividing this by 2 gives us 0.05. And so our T upper bound is 7.85. Okay. Finally, A, which is 3.4, rounded to one decimal place. This is the first, this is the second decimal place, so 0.1. Divide by 2. Did I say this is the second? Sorry, this is the first decimal place. That's it. And 0.1. This is correct. I think I said it in a wrong way. So now we'll divide this by 2, we get 0.05. And so A lower bound is the subtraction, which is 3.35, okay? So now I can go ahead and substitute each of my variables. So K is 13.5 as a lower bound, and T is 7.85, and A is 3.35. And now you can go ahead and plug these numbers on your calculator. Okay, and we get the answer is exactly 3. This is the minimum value of M. And by the way, when I said at the beginning of the examples, and the first example, that some students prefer to find the lower bound and upper bound based on demand, this is what I meant here. In this case, we found it on demand, you know. We didn't find K upper and lower, both of them, and then use what we want. We know that we only want the lower bound, so we only found that one. Okay. Some students prefer to find upper and lower for K, upper and lower for T, and upper and lower for A, and then use whichever they want. But I think that that takes up a little extra time. So it's better that you just find on demand. Let's move on to the next exercise. Okay, so again, pause the video, try solve it. Now, given that x is equal to 9.3, correct to one decimal place, and y is equal to 2.4, correct to two significant figures. Find the upper bound for z, which is the root of x squared plus y squared. Okay, so z is equal to the root of x squared plus y squared. Now, we want the upper bound for z. Now, this is the root. This is the last thing that will happen. Firstly, you will square the x, then you will square the y, then add them, and then take a root. Now, when you take a root of something, you always want the upper bound of it in order to achieve the upper bound for the square root. And when you go inside, you have an addition between two variables. So you would want the upper bound for this one and the upper bound for this one to get the upper bound for both of them. And the x squared, you would also want basically the upper bound for the x and the upper bound for the y. So this is fairly straightforward. Just want the upper bound for each of them. This is how you will get the upper bound for z. Okay, so let's go ahead and find the upper bound for x. X is equal to 9.3. Correct to one decimal place, so our unit of round is 0.1. Dividing this by 2 to find the error gives you 0.05. And so x upper bound is 9.35. As for y, it's 2.4. To two significant figures. This is the first significant, this is the second. Replace this by a 1, turn everything else to a 0, and divide by 2 to find the error. 0.05. Now, we want y upper bound, which is 2.45, okay? So now we'll go ahead and substitute our variables. 9.35 squared plus 2.45 squared. I will go ahead and plug those on the calculator. So we get 9.665 and a bunch of more decimals. Now rounded to 3 significant, this is 9.67. That's it, this is the answer. Okay, moving on to the next exercise. I think this is oh no, there are 4 exercises. Okay. So let's see. Given that m is equal to 15.7 correct to 1 decimal place, and n is equal to 4.8 correct to 2 significant figures, find the lower bound of t, where t is equal to m minus n over n plus n over m. Okay, so let's write this down. Just to zoom out. Okay. M minus n over n plus n over m. So we want the lower bound for t. The last operation you will do here, the first one is this subtraction, and then you'll divide, and then you go over here and divide based on the rows of operation of BIDMAS, and finally you will add. So the last operation you'll do is the addition. Now to achieve a lower bound from an addition, you would want this entire expression to have the lower bound, and this entire expression to have the lower bound. Okay? So now let's take first a look at the expression on the right. Lower bound for division. That means lower bound on the top, upper bound on the bottom. Numerator and denominator. That's it. You're done with the right hand side. Now, on this side, you want a lower bound, which also means a lower bound for the top and an upper bound for the bottom. So you're done with this part right here. Now, the denominator down here, it's done. However, the numerator, we still have an expression. You want the lower bound for m minus n. This is subtraction. So in order to achieve lower bound, you want the lower bound for m and the upper bound for n. Okay, so the upper bound for n. This will give you the lower bound for the subtraction. And that's it. Now you know what each variable is supposed to be. As you can see, for m, we're going to need a lower and an upper, and for n, upper and lower. So we got to find upper and lower for each single variable. Let's find this on over here. So m is equal to 15.7. This is correct to 1 decimal place, so my unit of round is 0.1. Dividing this by 2, we get 0.05. So m upper bound is 15.75, and m lower bound is subtracting those, which is 15.65. Now for n is equal to 4.8. N upper bound is sorry, I didn't find the unit of round. Okay, so we know that it's rounded to 2 significant figures. This is the first, and this is the second. So this is 1.0 divided by 2 is 0.05. I skipped to the upper and lower accidentally, even though actually they're the same. They have the same error. Okay, so n upper bound is 4.85 and n lower bound is 4.75. Now let's go ahead and substitute. Now m lower bound is 15.65 minus n upper bound, which is 4.85, divided by n upper bound, which is 4.85, plus n lower bound, which is 4.75, over m upper bound, which is 15.75, okay? And now you can just go ahead and plug all of those numbers on your calculator. So we get 2.528 and so on. Rounded to 3 significant figures, this is equal to 2.53. Okay, so this is the final answer. Moving on to the last exercise. The values m, n, and o are all correct to 2 decimal places. Find the lower bound for p. Okay, so let's go ahead and write p down. So p is equal to m over n plus o over m minus n over o. Now, this is fairly simple. So, firstly, according to BidMass, you will do all the divisions first, and then you'll do the addition, on the left-hand side, and finally the subtraction. So the final operation is this subtraction right here. It will be subtracting this whole expression from this entire expression. Now you want the lower bound for p. Okay? With subtraction, if you want the lower bound, you would want the lower bound for the first part and the upper bound for the subtracted part. So that's it for this expression. Now let's take care of the right-hand side because it's simpler. So we want the upper bound for n over o. This is a division. So you would want the upper bound for the numerator on top, and you would want the lower bound for the denominator on the bottom. And that's it for this over here. Now let's take a look here. Now you want the lower bound for this overall expression. In this expression, the last thing you'll do is add. You'll divide and then add. So for addition, you want to achieve the lower bound, which means lower bound for both. So that's it. I will erase those big brackets over here. So you want the lower bound for m over n and the lower bound for o over m. Now for both m and n, you want the lower bound. They're being divided. So you would want the lower bound for m and the upper bound for n. And also for o over m, you want the lower bound, which means you want the lower bound for o and the upper bound for m. Just let's do a little fixes here and there. And that is it. So again, lower bound, upper bound, lower bound, upper bound, upper bound, lower bound. And that's it. Now let's go ahead and find each of the bounds. So we have m is equal to 5.67. And for m, we want the lower bound here and the upper bound here, so we're gonna find both. Now everything is correct to 2 decimal places, so my unit of round is 0.01. Dividing this by 2 gives you the error 0.005. So this is going to be 5. Firstly, m upper bound is the addition of 5.67 plus the error, which gives you 5.675. M lower bound is the subtraction, 5.665. Now for n is equal to 2.34. Your unit of round is again 0.01. Your error is 0.005. And so n upper bound is equal to 2.345 and n lower bound is equal to 2.335. Finally, for O, it's 1.78. All right. And your unit of round is 0.01 again, and your error is the same, 0.005. So you can go ahead and find O upper bound is... We actually don't need O upper bound, by the way. We only want lower bound and lower bound, so No need to find it. Let's just find the lower bound. It's 1.775. That's it. Now let's go ahead and substitute our variables. So m lower bound is 5.665 over n upper bound, which is 2.345 plus O lower bound is 1.775 over m upper bound 5.675. Finally, minus n upper bound 2.345 divided by O lower bound, which is 1.775. Okay. And well, now you just go ahead and plug all of those numbers on your calculator. You can just plug the whole expression. You don't have to do it step by step. It makes it easier. And we get, wait, okay. So we get the answers equal to 1.41. This is rounded to 3 significant figures, okay? Okay, so that's it for upper and lower bounds and operations in between them. Thank you for watching.